notes, this is the last section of Unit 10. And we're doing more things with Desmond's lawn mowing job. I could go into Agile Mind and we could explain more of it, but honestly, once we get over the basic premise, it's pretty straightforward. So now Desmond he's bought a lawnmower, which was like lesson 1. He's figured out prices and which one's a better deal, old or new mower, and then he's figured out how many lawns he's mowed based on how much he made, or like which lawns based on how many he mowed total and how much he made off of them, and all that fun stuff. And now we're moving on to Desmond is building this business, and he's actually hired his friend Shelly to also help out, and she's going to do edging. So he does mowing and she does edging. Okay. And what are some issues they might consider? Well, there are a million issues they might consider. All sorts of stuff. But to keep things simple, I'm telling you, these are the 2 things that we want to consider for this. These are the 2 variables we're going to consider. How long will it take to mow a lawn versus edge a lawn? Sometimes that takes different amounts of time. In fact, it almost always takes different amounts of time. And how many hours can they each work? Maybe Desmond can't work as long as Shelly, maybe vice versa. Who can work longer? Can they work the same amount of hours? That's a very important question because that's going to affect how many lawns they can mow, or edge for that matter. Okay. Now remember, Desmond's not going to do any edging. Shelly's going to do the edging, and he's going to do the mowing. That's the way it's set up because that's the way that we set up the problem. Okay. So here's some facts that they give us. They tell us that it takes 1 hour to mow the small lawn and 2 hours to mow a large lawn. We also know it takes a half hour to edge a small lawn and 45 minutes to edge a large lawn. That's important. Now Desmond he has 30 hours. Desmond has 30 hours. Remember, he's mowing, so we're going to underline that in green. Shelly, on the other hand, she has 12 hours to work. Neither of them can work more than that. So you can see the green ones are what Desmond's dealing with. The purple ones are the ones that Shelly is dealing with. So, and they also want us to guess what we're going to make X and Y stand for. You guessed it. We're going to make X be how many standard size lots we have. We'll make that really big though. Make it 24, even more. Actually, no, 24 should work. Yeah. And number of large lots is going to be Y. Great. Okay. Now, how many hours does it take to mow one X lot? Well, it's a small lot and it takes 1 hour. That's what we said. So we'll say 1X. That's how many hours it takes to mow a small lot, whereas a large lot takes 2 hours. We're going to make this one be green to match, because this is what Desmond's dealing with. He's the mower, right? And we need it to be less than or equal to 30 hours, right? We need that to be less than or equal to 30 hours. Okay. However, our friend Shelly is the edger. It takes her a half hour to mow a small lawn. It takes her 45 minutes to mow a large lawn. She can only work up to 12 hours, so less than or equal to 12 hours. There we go. So a system of inequalities, we're set now. We just have to write, and I don't have a way, I might actually look this up, might as well. Actually, I could do this, I think. I can go, I'm going to try this. X1X, which is just X plus 2Y has to be less than or equal to, hey, look at that, less than or equal to, yeah. Hey, where'd you go? Come on. I hate this program sometimes. Here we are. Less than or equal to 30. That's one of them. Okay, we'll get to that in a minute. I'm learning how to use this, sorry. 0.5x plus 0.75y is less than or equal to 12 hours. Okay, great. There. That is our system of equations. One of them is our good friend, let's make it the right color. She's going to be purple. He's going to be green. Whoa, how did I cut it? I didn't know that I could put the background be green. There. Okay, cool. I learned some things. So hopefully that makes some sense. Ugh, I really don't like that text box though. It's just annoying. All right. Moving on. Sorry about that long wait. Okay, so we know that Desmond can't work more than 30 hours. We know that Shelley can't work more than 12. So we're going to pick some situations and see if they work. I've already written these situations because it's just painstakingly long to type it all out again. So there's the situation in which they mow 10 small lawns and 8 large lawns. Does that work for them? Well, all I have to do is make X be the small lawns and Y be the large lawns in each of my things. So I've got X is plus 2Y, because it takes 2 hours to do a large lawn. That's 10 hours for the small lawns. And for 8 lawns, that's going to be 16 hours for the large lawn. So for a total of 26 hours is less than 30. So that works for him. For Shelley, we got half an hour for small lawn and 3/4 of an hour for large lawn. So for 10 lawns, that would take 5 hours, half hour each. And for 8 lawns, that would take 6 hours, 45 minutes each, for a total of 11 hours, which is less than 12. So Shelley and Desmond are both not going overtime. They're both staying within their constraints. Constraint is something that holds things together, like something that you have to, a rule that you have to follow, or something you can't do, so that things work. Constraint for him is he can't work more than 30 hours. She can't work more than 12. That's her constraint. All right. Moving on, we got, what if there were 6 standard small ones and 15 large ones? Well, I can look at this right away and say it won't work. I can look at this and say, Desmond will spend 30 hours to do these 15 large corner lots plus this. And he can't work more than 30 hours. So that's going to be more than 30 hours. In fact, it turns out to be 36 hours total. 6 for the small lawns, plus 30 more hours for the large lawns, for a total of 36. That's bigger than 30. So this is not a solution. Desmond works too many hours. Next is, what if we had 6 small lawns and 12 large lawns? All right, let's see what happens. We've got, he's going to work 6 hours on the small lawns and end up working 24 hours on the big lawns for a total of 30 hours. He works exactly 30 hours. That works. For Shelley, she works 3 hours on the small lawns plus 9 hours on the big lawns, for a total of 12 hours, which is exactly what she can do. She can do that. That works for her. So both of them can do it. That's why this is called a solution, because it's within both of their constraints. Lastly, we have, what if there were 18 small ones and 6 large ones? Notice Desmond, that works for 18 hours for the small ones, 12 hours for the big ones, for a total of 30. Whereas Shelley, she spends a half hour on the small ones. So that makes 9 hours total for the small ones. She works 45 minutes on each of the 6 large ones for a total of 4.5 hours. And that does not work. That adds up to 13.5 hours. That's more than she can do. So this is not a solution because Shelley can't work that way. That's too long for her. It's not within her constraints. So hopefully that makes sense. We've had all the situations. This is when both can do it. It's within their constraints completely. It's like less than enough total hours. We've got one person can do it, but the other can't. Desmond cannot manage this. I don't know. I never checked with Shelley, but it doesn't matter. This one works for both of them, but it's right on their top end. They can't work anymore. And this one doesn't work because Shelley works too many hours. All right, so now we're going to graph them to see. The point is, I didn't type this out because it takes forever. You will know that if you're typing it in right now. It's very frustrating to double check, and I could keep doing this all day. We could just keep checking numbers after numbers after numbers. Wouldn't it be nice if there was a fast way to check all of these at once? And the answer is that there actually is a fast way to do this, and it involves graphing. We have to graph when we have systems of inequalities. There's no other way, okay? But I'm going to remind you how to graph problems like this in standard form, okay? So our steps are to first graph, okay? You have to graph we're going to graph the equation x plus 2y equals 30. Okay, we're going to find all the places where Desmond's going to work 30 hours. All right, on my math for a moment. There. All right, so we want the hours to add to 30. So you can have 28 and 1 or whatever else, right? The way we usually do this is I ask myself, what if he does 0 small longs? If x equals 0, that's small longs. So if he works no small longs at all, how many big longs does he have to work to get 30 hours? Well, at 2 hours apiece, he has to work 15 hours, 15 longs. So that gives me the point where x is 0 and y is 15. In other words, 0 small longs, 15 big longs. That gives me 30 hours. That's one point that I'm going to graph in a moment. The other point I'm going to graph is what if y was 0, if y equals 0. Now, the reason that I'm explaining it in real life is because just to understand what it represents. But we just I gotta put a 7 in there, 0. But we just turn x into 0 and see what that makes y. Turn y into 0 and see what that makes x. So now we're going to turn the x back to itself. We're going to make y equal 0. Well, if y equals 0, then 2 times 0 makes 0. Anything times 0 makes 0. So I have x plus 0 equals 30. Well, the only thing I can add to 0 to make 30 is 30. So another point is where x is 30, y is 0. These are the 2 points I have to graph. The next step is to then decide if the line is solid or dashed. Then decide. Then check 0, 0 to see which side of the line should be filled in. All right? So here's what we got to do. So I'm going to graph these points, 0, 15, and 30, 0. They're right here. Wait, this is our good friend Desmond, so I'm going to graph all of this in green. Make this be 6. This is the point 0, 15. And this is the point 30, 0. Those are the 2 points up here. Okay, it's very important you understand. All I'm doing is taking this guy and putting it here, and the other guy is going down there. Okay, and then I just connect them. I got a line. That's his line. This is all the combinations of 2 lawns that will add to 30 hours for him. So I could have 15 large lawns and no small ones. I could have 30 small ones and no large ones, or I could have something in between, like 10 large lawns and 10 small lawns, 10 of each. That would be right here. You can do all sorts of things, okay? And all of those will add to make 30 hours total. So this graph is helpful to me. I can kind of see where the border is, right? We don't want him to work more than 30 hours. So if I have more than 15 lawns up here, then it's going to be too much. If I have more than 30 lawns over here, it's going to be too much. If I have like, I don't know, 18 small lawns and 30 small lawns and 18 big lawns, that's going to be way too many hours. So I noticed that if I mow less than anything in this graph, any combination below this line actually works, okay? You can figure this out just by looking in this situation. But if you're ever stumped, what you can do is use the point 0, 0, okay? How does that work? Well, we want him to work under 30 hours, right? Well, I'm going to pick the point 0, 0. That's right here on the graph. What if x was 0 and y was 0? 0 plus 0, is that less than 30? Yeah. Yes, indeed, it is less than 30. So I know that that point down here works. I mean, he's not working too many hours if he works 0 of each, mows no lawns at all. So that works. And so I know anything on that side of the line will also work. So anything over here, any combination will give him less than 30 hours. He could mow 5 small lawns and 6 large lawns. We can mow 10 small lawns and 6 large lawns, or 15 and 6 large lawns. It doesn't matter as long as he doesn't go over 30 hours. All right, so that is Desmond. Now we're going to do the same thing with Shelley. I'm going to go to text. I'm going to click on here. I'm going to click on purple again because she's our purple person, right? Yeah. Purple is Shelley up here. Great. So Shelley, her equation, we're going to graph. 0.5x plus 0.75y equals 12. So I'm graphing it as an equals because I just want to find that line. Now, I talked about the line being solid or dotted. That has to do with whether it's allowed to actually be that number. So in this situation, we're talking about how many hours they're allowed to work. Can he work 30 hours or only less than 30 hours? There are situations where you can't actually be that number, right? So what we got here is like a speed limit, for example. As long as you are up to the speed limit, it doesn't matter if you're a little bit below. Well, it's not a good example. But there are situations where once you get to a certain amount, it's over. You can't be that amount, okay? So like some alarm systems are that way. If a certain temperature, a certain noise level happens, then the alarm goes off. It's not anything less than that works, but once you get to that level, it's over. So sometimes you have situations where we want to have up to a number, but not including that number. Other times we want to include that number. This is one of the second situations. We're allowed to work 30 hours. She's allowed to work 12 hours. So I make the line solid to show that on the line is okay. 30 hours is okay. Down here, on the line will be okay. 12 hours is okay. We'll have ones later where it's not like that. Okay, so let's see. I'm going to do this one fast if that's all right. X equals, see if you can figure this out. If x equals 0, then y must be, that would be 0 here. And the answer is, divide 12 by 0.75 to get 16. And if y equals 0, then x equals, well, that's going to be 24. I promise you that that's right. Okay, so that's going to give me the point 0.16. This is going to give me the point 24.0. I'm going to graph those points now. I'm going to graph them in purple so that it matches. 0.16 is right. Make that larger. And 24.0. All right. Next, I'm going to connect them with a line. So this is an example of what's going on with our dear friend Shelly. This keeps track of all the possibilities of things that add to 12 hours for her. If she did 16 large lawns, that would add up to 12 hours. If she did 24 small lawns, that would add up to 12 hours. Okay, that's what we figured out. Anything in between also works. So like right here, she could do 6 large lawns and 15 small lawns. That would work as well. Okay, so there are lots of possibilities there, but she's not allowed to work more than this. So just like with our dear friend Desmond, Shelly can do anything in this area below, but she's not allowed to do anything in the area above this line. Because she can work less than 12 hours. She could do 8 small lawns, 8 large lawns and 5 small lawns. I guarantee you that'll add to less than 12 hours, so perfectly okay. So I can double check all sorts of possibilities. What about 10 small lawns and 6 large lawns? Perfectly okay. 10 large lawns and 8 small? Yep. 10 and 9? Looks like it. That'll come in just under 12 hours. So you can see that this is a useful way to check lots of possibilities all at once. Okay, so how am I going to combine these though? The answer is just put them on the same graph. I can keep track of what's below his, I can keep track of what's below hers, and I can make sure that everything that I pick is below both of those lines. So in the next one, we're going to sketch both graphs. I'm not going to redo anything. I'm just going to copy the same line down, just so you know. So I went from 15 down to 30 for his. So let's really quickly go here. 6, 15, boom, and 30. All right, and for her, we've got, I don't know, I might connect them. There. Okay, and for our friend Shelly, we went from 16 down to 24. I'm going to connect those ones now. 16 down to 4. All right, I'll connect that. There. All right, so these are their lines. All right, and here's what I noticed. They're not perfect, right? The purple one starts out on top and it ends up on bottom, right? And I want to make sure that I don't make either person work too much, right? So for example, up here, this is if I had 20 small lawns and 16 large lawns. That would be way too many hours for both of them. It's on the wrong side of their line, just like we had up here, right? However, if I did 5 small lawns and 2 big lawns, that should work. It's well within what they can do. It's below the purple line and below the green line. So that one's acceptable. So how do I keep track of this? Well, I would accept anything below his line and her line together. That is the area we're allowed to use because that won't make either person work too many hours. Okay, as long as I'm below the purple line, it's going to work for Shelley. As long as I'm below the green line, it's going to work for Desmond. As long as I'm below both lines, it's going to work for both of them. And that's how this works. Okay, so for example, this number right here, that's 25 small longs and 2 large longs. That's going to work for Desmond because Desmond's the green line and it's below his line. But it should not work for Shelley because that's not below her line. Okay, and that's the power of using graphs. I can check all sorts of possibilities on here and I can make sure that they work. I don't have to plug anything into an equation. All right, so let's keep going. So here's one thing that we're below. Here's another thing that we're below, and there's their equations, and that's great. They're the same two that we had up here. We were just combining them. Now, Desmond says because neither variable can be negative, we really have a system of 4 inequalities, not just 2. And this is technically speaking true. Because we can't have negatives. What is he getting at? Well, usually graphs are bigger than this, right? Usually graphs go out this way and like that, and there's an x-axis and a y-axis. Why don't I have stuff over here? Why am I not keeping track of stuff over here? Well, for example, this is small longs, right? If I was over here, that would mean I was, well, this is 0 small longs, -1, -2, -3, -4, -5. Wait, I mowed -5 small longs? What does that even mean? And the answer is nothing. It means nothing. That does not make any sense. So I don't want to keep track of negative numbers. We're not working negative hours. We're not mowing negative lawns. So technically speaking, there are 2 more lines that we're not supposed to be past. One of them goes this way. And the other one goes, we'll go with red, this way. Everything has to fall in that area because we can't have negative lawns. All right, and so what he's saying is there are actually 4 lines that we have to be above. We have to be below the 2 that we just mentioned up here. Also, both x and y must be positive because there is no such thing as a negative 1. Okay, so other ones are we have to have x has to be greater than or equal to 0, and y has to be greater than or equal to 0. And that's what they're looking for. Okay, Desmond also continues. Also, notice that the point 10, 8 is below both of the lines. Okay, what does that mean? Let's find the point 10, 8. 10, 8 is right. Let's make it be, we'll make it be red so we can see it easily. Oh no, we'll make this be red so we can see it easily. Stop it. 8, 10, right? Was it 10, 8 or 8, 10? 10, 8. Whoops. 10, 8. That's right here. Notice it's below the lines, isn't it? So if it was above the pink line, then Shelley couldn't do it. If it was above the green line, then Desmond couldn't do it. So since it's below both lines, then it must work. Since the point 10, 8 is below both lines in the graph, it will not require either person to work too many hours. That's what it means. And he's right. It does work. We checked way back when. 10.8 was way up here. 10.8. And it worked. 26 hours for him, 11 hours for her. And yeah, just a little bit below 30 hours for him and a little bit below 12 hours for her. Look at that. It works. So good for us. We're going to use that to check more points. Okay. All right. We're going to zoom out a little bit so you can see the screen better. We're going to answer some questions about the point 615. The point 615. Okay. The point 615 is where 6 one less than 5, one more than 5. 15 is right there. So 615 is this purple one. Does it work? No, not in the yellow area, is it? Oh, there's the 10.8 we were talking about earlier. Okay, so it's above both lines, would you agree? Yeah, so I'm going to say it falls above both lines. This corresponds to, does it work for either of them? No, it's too much, too many hours. It's outside of the range of both of them. It has to be below both these lines for it to work. So it corresponds to neither of the people. Okay, how about the point 618, 612, 612, okay. 612, I will just tell you, it should be better than this. 612 is right here. And it works, just so you know. It's on both of the lines. That's where the lines cross. This is a bad graph. So, bummer. All right, so it falls on both lines. Which means what? That means they're both working exactly 30 hours. Is that okay? Yeah, it works with both of them. It corresponds to both of them. Finally, we have 18.6. 18.6. Let's find 18.6. 18.6. 18.6 is on the red line. Okay, I promise you. What's going on there? Well, that means that it works for whoever the red person is. The red person is Desmond. The blue person is Shelley. So that works for Desmond, but not Shelley. All right, so let's see what that means. Falls below on that line, on Desmond's line, and below the other one. This means that Desmond is the exact time required, but Shelley, too much. Yep. All right. They allocated more time this week. Okay, we're getting there. We're getting to the last problem. It's good. This is a long video. We're getting there. Okay, so we've got this. They're going to graph more. We got 615. We're going to check these points and use the situation. I mean, technically, since I only have 2 points I need to check, this would be faster to check without a graph. You just be like, well, we'll see. They got the same situation. So does this make him work more than 36 hours or her work more than 15? And I could just plug it in using the information we've had already, which, if you remember, it takes 1 hour to mow a small lawn, 2 hours to mow a big lawn. So let's make that happen. 1 hour to mow a small lawn plus 2 hours to mow a big lawn for a total of, and it says now Desmond has 36 hours and Shelley has 15 hours. So that's going to change our setup. Just going to be like continues to work less than or equal to 36 hours. And she still takes 0.5 hours to mow, to edge a small lawn, and still takes 0.75 hours to mow a big lawn. And that's still got to be less than or equal to. But now instead of 12 hours total, she can work up to 15. That's the difference. So the only thing that really changed is they're adding to a different amount. That's good to know because the graph's going to look very similar. Lots of things are going to look similar, but we'll have slightly different answers. So to graph this, we'll do Desmond first in green. Desmond. I'm going to graph the x plus 2y equals 30 first. So if x equals 0, then y equals 15. Oops, I meant 36, which means that this is now y equals 18. And if y equals 0, then x equals 36. There we go. So what do I got? I got the point 0, 18, and the point 36, 0. Next, I need to go on to Shelly. Shelly likes. Oh, nope, 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 nope. Nope, nope, nope. Okay. Now, I can click on Shelly's. She has 0.5x plus 0.75y equals 50. No. Yeah, we're just going to do equals because we're graphing 15. Right? Okay. So what's that leave me with? So I want to see if x is 0. Equals, well, if x equals 0, I'm going to make this to a 0, and then I have to figure out 0.75 goes into 15 how many times. It's going to be, oh gosh, 20. Y equals 20. And if y equals 0, then x equals 3. So I get the point 0, 20, and the point 30, 0. Those are my 2 points. Now I just have to graph all of these. Notice my biggest number is 36 for y's. My biggest number is 20 for x's. So I have to make sure I count correctly for that. I'm just going to count by 2's because it'll work best. All right. So I'm going to go down here. Do black. 2, 4, 6, 8, 10. 12, 14, 16, 18, 20. 22, 24, 26, 28, 30. There's that. 2, 4, 6, 8, 10. 12, 14, 16, 18, 20. 20. 20. In the right spot now. 14, 16, 18, 20. And one more. 30. 2, 24, 26, 28, 30. There. All right. So now I just have to graph it. I'm going to go over here. I'm going to pick green for Desmond. Graph the point 018. Point 018 is 0, 18. And the point 360 is 3246. That's right here. And I'm going to connect them. Hope you see this way that I'm graphing. This is how we graph in standard form. And lastly, I go to purple again. And I do the same thing with our friend Shelly. Shelly, point 020 right here. There. And 030. There. All right. And 1. There. There's their graph. Notice they cross about here or here. I'm not sure where. They this one's crosses there. This one crosses there. That's fine. We want to be below both of them, don't we? Yeah. It's still the same. Still the same situation. So I need to be on this side of the line. Now we got a graph. Now I just need to check the viewpoints that they gave me. Where are the points that they gave me? Let's see here. I could plug them in, but now that I have a graph, I might as well just check them on here. Okay, so I'm going to find my point black. I'll make it size 6, and we'll go up here and we'll ask, what about 615? Where's 615? 2, 4, 6. 2, 4, 6, 8, 10, 12, 14, 15. 15 is right there on the green line. So it looks like it works, doesn't it? Yeah. It's right on the edge for Desmond, but it's clearly below Shelly's. All right, so that works. How about the point 18, 6? 18, 2, 4, 6, that's right here. And the answer is both solutions represent solutions. Both points represent solutions, both this one and that one, because they're both below the lines. Neither person should work too long. And you can double check if you want, but the whole goal is that we can figure it out using the graph. So I'll zoom out there so you can see it better. It's a bit of work. Good practice. All right. We're going to solve these ones quicker. Okay, I'm just going to really quickly make some lines. 2. There's that stuff. I'm just going to really cut and paste this guy so I can use him for the next one. Control C, Control V, down to there, so that we got another graph. All right, and I think, nope, there is one more. Yep. There. All right, so now I have my graphs finished. Now I'm going to put size 6 here. I gotta find out, no, these are in y equals mx plus b. I know you can use graphing to solve it, but we're gonna not. We're going to use y equals mx plus b. So I'm gonna find I'll make this one green, and this one pink. For the green one, I know my y-intercept is 4. 1, 2, 3, 4, right there. Oops, wrong color. 4. 1, 2, 3, 4. For my pink one, I know my y-intercept is -1 because that's what we graph in y equals mx plus b form. Next, I know that this one's -3/4, which means it goes down 3 and over 4. Okay, we've learned this way back when, before I even left. So what's that look like? Down 3 over 4. Here. Down 3 over 4. There. 4 up 3. Over 4 up 3. There. And the other one, it's going to be over 2 and up 1. The idea. All right. So now what do I do? Well, now I have to connect the dots, but I have to also look at these things. Notice the green one has no equals sign. That means it's not allowed to be on this line, only above or below it. It's not allowed to be on the line. So what that means is I have to make this line be dashed, dotted, like so. Like so. Now the pink one, however, does have an equal sign. Notice it has an equal sign right here below the thing. That means it's allowed to be on the line, just not, well, yeah, it's allowed to be on the line, not just not anything. There. So there's my 2 lines. Next, I need to ask myself, what side of the line am I supposed to fill in? Now, you might have learned to always fill in if y is greater than, to fill in above the line, if y is less than, to fill in below. That works in this form. In later forms, it does not work so well, okay? So we're going to have to work on a All right, and I'm back. We're graphing the last couple. One more graph and one more word problem. Here we go. This one. This is also y equals mx plus b form. So I'm going to go through the same things. This guy is green. This one is pink. How we can keep track of them. Green has a y-intercept of 2. Pink has a y-intercept of -3. Green has a slope of -1. Oops, I'll make that smaller. And it's dotted. It does not have an equal sign. So I'm going to go ahead and I'm just going to go ahead and fill it in right now. That means it goes like this. Goes over one, down one, perfectly diagonal. Close enough. And one thing you should remember, I mean, obviously we're not using these graphs for much right now. The graph is only as useful as the person making it, okay? So always remember, like if you are, let's see, that's -6x. That's a -6 slope. So that's over 1 and down 1, 2, 3, 4, 5, 6. Over 1, 2, 3, 4, 5, 6. There we are. So if you are trying to graph a line and you're sloppy about it, then you use that graph to find anything out later in life, that graph's not going to be very helpful. So learning how to precisely make a graph, that is terrible, but we are on Zoom or on Kami, so I'm going to accept it. Point is, we need to know whether we get things are doing things right, and we need to be as careful as we can. Try your best to make the graphs straight lines. You know, especially if you're going to use it for something, it needs to be a straight line. All right, 0, 0. Does 0, 0 work? That's going to be 0 is less than 2. Hey, that works. Down here we have 0, 0. 0 is greater than -3. Also works. So 0, 0 is on the proper side of both of them. So that means the pink one, 0, 0 is right here. So I'm going to be on this side of the pink guy. And I'm going to be on this side of the green guy, 0, 0 side, 0, 0. And where do they both cross? Where it works for both equations? It's the one down in the bottom right corner. I'm going to erase all of these guys. I'm going to erase all of these guys. And bada bing, bada boom, there's your graph. It looks very almost Christmassy. All right, fun. Last one. Souvenir Ballpark sells signs, baseballs for $2 each and enforces minimum or signature bats for $6. Jay can spend $12. Jay, okay, so $2 for a baseball, $6 for a bat. Jay spent $12. He bought no more than 4. Okay, so if we add up the baseballs, we're going to make X equal baseball, Y equal bat, because that's what we're buying. That's our variable. I add up all the baseballs and bats he bought. Baseballs and bats he bought. That's fun. X plus Y. X plus Y. It adds up to 4. He bought 4 things. Now we're going to add up how much it costs. Well, the baseballs were $2. The bats were $4. And the total is $12. That's our money equation. Money. Okay, so what do we end up with here? We need to, oops, I did not use these as equations. I need to use these as equations. He bought no more than 4, so he bought up to 4. He could have bought 1. He could have bought 2. He could have bought 3. Could have bought 4, but no more. And at most 12. So he could have bought $0 or $8 or $6. I'm not sure. Okay, that's better. Now we got a system of equations. And these equations are nice and easy to graph. 2 goes into 12, 4 goes into 12, 1 goes into 4, that guy goes into 4. Okay, so I'm going to graph them. I'm going to do this rather fast. I'm going to make this one be green. This one be pink. Okay. So green one, notice they're both less than or equal to, so I can just make a solid line. I'm going to make a graph here. We're going to do it. It's going to be like our previous problem. So it's going to be a graph where the lines go like this, because we can't buy negative stuff. So we start at 0. We're going to count, oh gosh, 4, 6, 3. It only goes up to like 6. I'm going to count 1. I'm going to count by 2s. So we're going to go with 1, 2, 3, 4, 5. We probably could have counted by even bigger numbers or bigger amounts of space per number, but life goes on. Okay. I'm just telling you what to do here. So I want you to think about there. I'm just going to go up to 5 there because I'm tired of typing in numbers. Okay, so if x is 0, y is 4. If y is 0, x is 4. In other words, if I spend $4 on, if I buy 4 baseball bats, I can't buy any baseballs. If I buy 4 baseballs, I can't buy any baseball bats. That's my first graph, the line that I'm going to create. I'm going to go down here and I'm going to find this number and I'm going to say if I buy 4 baseballs, I can't buy any bats. If I buy any bats, I can't buy any baseballs. I just did 0.04 and 40. Okay, so that's my first line. I can buy 3 of one and 1 of the other, 2 of each, 1 of one and 3 of the other, or none of one and 4 of the other. That's what this line is telling me. The pink one here, 2x, I'm going to actually type that one. If x equals 0, y equals, well, if this was 0, 4y would have to make 12, so y would have to be 3. If y equals 0, x would have to be 6. 0, 2 times 6 is going to make 12. All right, so I'm going to graph that one. 0, 3, and 6, 0. 6, 0 is the graph up here. 0, 3 is down here somewhere. So I'm going to go like so. I had that backwards, my bad. I'll fix it here. 0, 3 is right here. 6, 0 is down here. But this is what the prohibitive cost. Okay, so this, if I bought something up here, that means I bought the right number of items, but it costs too much. This means I bought something that costs too much, but it's still the right, no. Yeah, no. I bought something that costs the right amount, but it's too many things. Like say I bought 4 $2 things. That's the right amount, but it's not the right number of things. Or 6. I'm just rambling at this point. This is our graph. Most of the time in real life, this is what the graph looks like. Okay, so that's what we got. This is our area. This, let's see. We'll just really quickly type a few things here. We're going to say too many things and too expensive. All right, over here we have right amount, but expensive. And then over here we have right price, but too many things. And we'll just really quickly label that so you can see what's going on. I'll make this one be blue. I'll make this be blue as well. Won't do that because it looks like another solution. I'll make this guy be green, no, red. All right, and then this guy over here is gonna be yellow. And then purple is our solution. Purple is our solution. That's the right price and not too many things. So that makes sense, hopefully. I'm done.